Multiplying these would suck. It's just a lot of writing. Okay, is it possible? Is it really hard? No, it's just annoying. Okay, and there's nothing more that I hate than annoying mathematics, which is why I do not like statistics, because it's annoying. Okay, but I want to teach you guys a trick today by using something called combinations or the Pascal's triangle. And that is better known as the Binomial Theorem. But in order for you guys to appreciate it, I want you guys to multiply these dudes out. Okay, so now long ways, an Algebra 1 student would come in, they'd be able to do this, not proud. Maybe even a pre-algebra student. Here, let's do the work for it really quick. Doing out this exponent right here would require you to multiply all these together. Yes, lots of writing to do. Here we go. So this is what we get. It's hideous, I know. The first time I just multiplied these two. The next time I multiplied these two. And then the last one I multiplied these two. Okay, so that's what you get when you multiply x plus y 4 times. This is our answer. Nasty. Nasty, nasty, nasty. You got to be really careful too, because with this much writing, it's so easy to make mistakes, as you guys saw that I was making mistakes. So I'm going to press pause on this guy. Okay, we're going to wait on him. We're going to look at this for a second and try to notice some patterns. Do you guys notice any patterns? Talk to your neighbor about it. Now, some of you guys, surprisingly, were able to relate this to Pascal's triangle. I mean, that was a whole 4 days ago or 3 days ago. I gave that to you guys, and some of you guys saw that. Pascal's triangle. Do you guys want to? Here, let's be reminded of that. It goes 1, and then it goes 1, 1, and then 1, 2, 1, and then 1, 3, 3, 1. What's going on here? And then 1, 4, 6, 4, 1. Do you guys see what's happening? Every next line, I add the 2 numbers right above it. So 1 is always going to be first, and then I add these 2 numbers. What do I get when I add those 2 numbers? 5, and then I add these 2 numbers. What do I get when I add those 2 numbers? 10, and then a 10, and then a 5, and then a 1. And so every time, we're just adding the 2 numbers above it. And you guys see those? See those numbers? Okay, look at this. This is when you have a power of 0. This is when you have a power of 1. This is when you have a power of 2. This is when you have a power of 3. And this is when you have a power of 4. And that, my stews, is what we're looking at right there. 1, 4, 6, 4, 1, which is the same pattern we have right here. We have a 1, a 4, a 6, a 4, and a 1.
Radical.
Yeah, pretty neat, huh? Okay, and then you guys see the other pattern. Maybe you guys saw the x to the 4th, x to the 3rd, x squared, x, and then no x. And then the second term, which is the y, he counts up. This is no y. This is y to the 1. This is y to the 2. This is y to the 3rd, and y to the 4th. So there's patterns here. And we can use these patterns to help us know what terms are without having to do all this stuff. And I'm going to show you right now. Okay, so write this out. Wait, first of all, how many terms do we have? We have 1, 2, 3, 4, 5 terms. Do you guys think that's in any way related to this? You are right. They would say something like this. There are n plus 1 terms in your polynomial. Okay, there's n plus 1. What does n represent? N represents your power. Okay, so this is n right here. This is the nth row. You guys got that? The nth row. The first one starts with 0 and it goes like so. Okay, so how would you help this pattern or make this pattern work for you? You would go like this. Each term has 3 parts to it. Each term has 3 parts to it. So let me write that out really quick. So here we have 5 terms. 1, 2, 3, 4, 5. And each of them has 3 parts to it. The first part, this is your Pascal's triangle number, or you guys can call it a combination number, which we'll get to in a second. These 2 are the ones I really want to talk about right now because those ones come from these 2 terms that are inside our binomial. This is the first term in our binomial. This is the second term in our binomial. So it goes x, y, and all these get an x and a y in them. Now the thing about these 2 for each term is they all have a power. and you guys have to know what those powers are. But it's pretty simple. This is the easiest pattern that you guys might have recognized. The first term is going to have a power of 4, the n. The second term is going to have a power of 0. Is everybody with? Yes? Actually, I want to write that power in purple. Okay, so this would be 3, this would be 2, this would be 1, and this would be 0. Yeah? Yeah. Okay, the next one is going to be 0, 1, 2, 3, 4. Now, where are those other missing numbers going to come from? These guys. Pascal's triangle. Okay, and so we just have to write in there 1, 4, 6, 4, and then 1. Okay, now this is pretending that we didn't have to do all this work right here. You just go straight to this. Now we simplify. Now there's not that, this simplifying is not that hard to do because look at this term. How hard is that to simplify? X to the 4th. Ooh. Because anything raised to 0 power is 1, so you don't have to worry about that one. This one's 4x to the 3rd y. Ooh. Okay. Look how complicated this is. This is not that complicated. It's not complicated. It's not what I said. All right. Joking. Now we're going to do this one in a minute. I'll probably say that for the next video. But what I want to do here is I want to show you guys how else you can find the 4, 6, and the 4. Okay, you can use Pascal's triangle. You can. Okay, but there's another way you can view this. And that's with combinations. Combinations can be written in 2 different ways. Let's take this guy for, would it be that guy? I don't know. Here, let's find out. Let's take this for example. Let's go 4, choose 2. Okay, 4, choose 2. This can be written like this. 4, 2, like that. It's not a fraction. It's actually saying the same thing. It's just a different way to write it. Okay, so normally it's said as 4, choose 2. Okay, that's how it's normally said. And so I'm just going to give you guys this formula, and then we're actually going to work with this later today so you guys understand it a little bit more. The top number, does anybody know what the top number is on this, like for the formula?
4.
Yeah, for what? 4 factorial. Don't.
4.
It's 4. Okay. On the bottom, we have 4 minus 2. Yeah. Okay. And then we have a 2 factorial. Okay. This is the formula. Now look what happens when we do it. So we get 4 times 3 times 2 times 1 on the top, and on the bottom we have a 2 factorial and a 2 factorial. So we get to cancel some stuff out. Now I could have stopped right here and put a factorial right here. I mean, 2 factorial is not really special, but we can cancel out those right there. And guys, what is 2 factorial? It's 2 times 1, right?
2.
So is there anything else I can simplify? If this is a 2,
12 divided by 2.
yeah, I can say this is a 1 and this is a 2, right? Right. So what do I get on top?
6.
I get a 6 and it's being divided by 1, which is just 6. Okay, so can we relate this result to this guy right here? It's this one, right? Okay, so how would we know that this is the middle one? How would we know that? Like,
It has 2 words.
okay, so I gotta erase everything to get you guys refocused here. If the question says, find the third term. Find the third term. That's supposed to be an R. Third term. What is the third term for this? Okay, and this is what you would think. Well, I know patterns and such. I know that the third term is going to have 3 parts to it. Yup. If you know that the third term has 3 parts to it, you guys know that the X is right here, the Y is right here. Do you guys know the powers? This is the third term.
Yeah.
You guys remember what happened to the first one? What was the pattern to get down to the third term?
Down.
It's counting down, right? Starting at what? At 4. So 4 would be the first term, 3 would be the second term, 2 would be the third term, right? What would the Y? What term would the Y have? Or
0.
what power? Starting at 0, and then we go 1, and then it go to 2, right? So they both have the same powers, but that's just a coinkydink. But what would I put in there? Why would 4 and 2, how would you know it would be 4 choose 2? How would you know you choose the 4? And how would you know to choose a 2? Tell your neighbors, go. You know the 4? because of the power. You know the 2, and this is kind of handy, it's convenient. The 2 actually always matches up with that. It always matches up with the second term. Okay? You can call this n, and you can call this the term you want. So it'll be the third term minus 1. It's always the third term minus 1. It's always like 4 minus 1. It's always something minus 1. So, like, for example, if you had a different problem that said, find the fourth term, then you would be like, dit, and you would be like, oh, I know this is x, I know this is y. I know that since we're trying to find the fourth term, then this is going to be 3 right here. And since I'm trying to find the fourth term, I know that this is going to be a 3 right here, and this is going to be a 4. 4 choose 3. This is the fourth term. That's how I know these 3s right here. So how do I know what this one is going to be? I can go through that thing and I can do the pattern thing, but is there a faster way to do it? Heck yeah, there's a faster way to do it. You go 4 minus 3. What do you get? 1. That's how you know what the power is for that one. Pretty rad stuff, right?
Wow.
I already did this one. The formula for it, so I'm not going to spend time doing that one. That one you know is 6, and you know it's x to the second power and y to the second power. That one's done. That's the third term. To do the fourth term, you would go 4 factorial over 4 minus 3 factorial, and then 3 factorial. That's this formula right here. And so you have, this is going to be a 1 factorial, which doesn't do anything, so he's worthless. Who cares about him? And on the top, we have 4 times 3 factorial, and I'm going to stop at 3 factorial because then I can cancel those out, and we get 1s for there, so it's just a 4. So this equals 4x y to the third. So that's what the fourth term would be. So now, this one is a really simple one to do. This one is a little bit harder, but it's not that much harder. I want to do that one next. So for this one, I want you guys to find the third term.